Linear regression is the most basic and commonly used predictive analysis. These linear models are used to show or predict the relationship between two or more variables. Understanding the importance of linear regression, we have come up with this linear regression tutorial. Now, before we go ahead with the session, I'd like to inform that we have launched a completely free platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below. Now let's have a quick glance at the agenda. We'll start off by understanding about correlation. Then we will learn about regression. After that, we will comprehensively look at the mathematical concepts of linear regression.
So now let's get back from the digital world, okay, to the analytics education. Okay, so who will define regression for me? Dependency on independent sensitivity. What are these independent dependent variables? Input and output, okay. So that's good way of putting. What else? What are we doing here with the help of this subject? We're trying to explain things, yes or no, right? We're trying to unfold the hidden patterns, yes or no, correct? That's our objective, correct? So I am kind of explaining things, okay? So you have been studying and you have been understanding things that in everything, right? We talk about PCA, we talk about other techniques. There is something, one thing is common, which is called variance. Yes or no? Yes. So you always try to explain variance, correct? Yes or no? Right? Everyone, same page? Variance? So if I want to put in that terms, I can put something as explained and something as explanatory, okay? So something called explained and something explanatory. So my objective here is to explain something with the help of explanatory, yes or no? Correct? Okay, so something which is explained with the help of explanatory. So my explained will be what? Right? My explained will be y and my explanatory will be x. So you remember those school days, y equal to mx plus c, right? So I'm looking for y always with the help of x, right? So same way, if what regression helps me to explain variance in y with the help of variance in x. In simple terms, that's regression. It's a technique which helps me to explain variance in y with the help of variance in x. That's it. Simple. Now you can, make this as dependent, these are independent. You can get to the nomenclature. But from the core, that's what regression is. Okay? Remember this. Okay? Simple, clear. So this is correlation, you already know, right? It's a measure of association between two numerical variables, positive, negative. Example, summer, temperature increases, thirst also increase. ज़्यादा गर्मी होती है तो प्यास ज़्यादा लगती है. Okay? Negative, as the rate of a product increases, number of items sold decreases. Yes or no? But in case of iPhone, it's different. So statistics goes to a toss there. Yes or no? Brand loyalty is more there. Right? So you should always answer. Find the reason why. Why in iPhone it's not there? As they make more expensive, lines are bigger outside the stores. Yes or no? Correct? So that's how it is. Outliers. Or our analysis goes for a toss. Okay. How relationship is measured? Basically with the Pearson coefficient, which is called small r. So what is the way to analyze correlations? Scatter plot. Okay, everybody knows how to draw it. No correlation, random or circular assortment of dots. Positive, ellipse leaning towards right. GPA and SAT score. If your SAT score is high, the GPA will be also higher. Smoke and lung damage. ज़्यादा smoke करेंगे तो, दिल्ली में ज़्यादा रहेंगे तो, if you stay, right? Term insurance और ऊपर से वैसे भी ये good insight. If you stay in Delhi, obviously your life insurance has to be more, right? Premium wise. Okay. Negative correlation, ellipse leaning towards left. Depression and self-esteem. You're depressed, your self-esteem low. Studying and test errors. More you study, errors are less. Value, 1 is perfect, 0 is no, -1 is perfect, negative. So it lies between 1 and -1. So this is how you should, from the graph, perfect, linear, positive, no correlation. Interpretation, strong association, moderate, weak. Positive, negative. Again, same thing, closer to M, stronger linear relationship. Okay, so this is what I was talking about. So is a tool for finding relationship between explained variable and one or more explanatory variables in a study. Okay, so relationship can be linear, non-linear. The basic function of regression is to identify statistically significant explanatory variables and estimate the model parameters. Okay, definition wise everybody is same page? Good. So why we do regression analysis? So there are multiple use cases, right? You need to identify how MRP affects the purchase decision, right? So that will help me. Which promotion is more effective? What is the risk associated with the price increase on customer retention? Which customer is likely to default? What percentage of loan is likely to result in a loss? How to identify the most profitable customers? Okay, these are all regression use cases. Where it is used? Everywhere, mostly everywhere, right? So now new domains are coming up. So like but high level, finance, marketing, operations, HR, healthcare. Types of regression, one and more, again linear and multilinear. You already know this. Okay, a simple regression is written as y equals to beta naught plus beta 1 x. Same in the form of y equal to mx plus c. Okay, so guys, let's do a problem. Okay, let's see how much we can do. Okay, so problem here is a B school, let's assume a B school like Great Lakes, okay, wants to start a new batch of analytics course. Okay, it would like to estimate the number of application it can expect for next year admission. Okay, so that's the problem. So below are the data points given by the school, year, which year, first year, second year, like that, application number, number of applications whenever a new course was introduced, right? So their problem is they want to launch a new analytics course or an analytics course, but they have not done that before. Okay, so now what best data they have, that in the past if they have launched a new course, what were number of applications? Okay, as a brand or as a college they want to see. Okay, second one is average placement rate. So basically they are launching a upskilling course, reskilling kind of. So they will first check on that year the people who graduated from the college, what was the placement rate for that? How many of them got jobs? Sometimes you are so motivated that instead of placement also you go for education. Sometimes you would say, let me work sometime and then I go for reskilling. You know, so that's what the data point is. And then number of undergraduates who would graduate in the current year. How much students are getting free from the college this year. So I can target that with a target segment. Okay. So this is the data. You all have LMS logged in. So there is a data set called student. You can see that CSV, student data set. So just get that into your working directory or right now. So problem here is, see, given the record for last 15 years, predict the number of application using the placement rate. You understood the problem? Given the record for last 15 years, predict the number of application using the placement rate. And then what is the expected number of application given this year placement rate was 60%. Okay? Understood? So this is the data. Okay? And the problem is, given the record of last 15 years, predict the number of application using the placement rate. Okay? And what I have to find, what is the expected number of application given this year's placement rate was 60%. Okay? So first we'll do it in Excel. Okay? Have you done regression in Excel before? So you will do it yourself? Yes or no? No? अच्छा करा है पहले लेकिन हम करेंगे नहीं खुद सब कुछ मुझसे करवाओगे. You saw the data set? So what are the columns? Year, placement rate, applications. What else? Serial number is here, first year, imagine, right? Okay. Okay, application number, average rate. Okay. Graduation number, right? Placement rate and graduation number. This is what the data is. Correct? So year is something like, you can consider this is 15 years data, like that. Okay. Think that way. It's not a variable for us. It's a 15 years data. Okay. So how you will do this? Data analysis. Right? Go to regression. Okay. So now you will give your input. What is my Y here? application number. Okay. So this is my y. What is my x? Average rate of placement. That's my x. My first row is label. Okay. That's it. Shall we do? Go ahead. Okay, regression? Done? So, done? Shall I do once more? हाँ जी, repeat करेंगे. कर लिया? कर लिया ही? समझ आ गया? So now do this in an easy way. Okay? How we will do this in an easy way? In R. So now how to do it in R? So this is how you do in R. I've given you the code, just follow it and let me know once it's done. R. Launch your R session, set up your working directory, put that data set into your working directory, and I hope you all know how to set up a working directory. What is the function for setting a working directory? setwd. Good. Go ahead. You can do it through the menu option also. In RStudio, there is something called session, and then there is change directory there. Working directory, sorry, not change. Do it in R quickly. Done? So what I am doing here, model is my result is my model name, lm app underscore number regressing on average rate placement data equal to s, which I have read here. Okay? I'll get the summary of results with the help of summary function. So okay, you had already have an output in Excel, right? Correct? Everyone had an output in Excel. Excel बंद तो नहीं की ना अभी? वो जिसमें output था, ठीक है? वो Excel में था और एक ये output आया. दोनों को compare करो, right? So I'll come to this. Okay, so this is output interpretation, correct? ठीक है? तो इसमें what are the things we will look for? Okay, one is the intercepts. Okay, so what are the intercepts here? हाँ, this is 1 3. So इस term में intercept क्या होगा? M या C? Everybody agree it's C? ठीक है, right? So जो ये C है, that is my intercept, correct? And X क्या है मेरा? X is और M का होगा? What is my M here? Minus 158.02. That's my M. Now you, okay? Y equal to beta naught plus beta 1 X. Got it? ठीक है? So Y is my what? Application number. Beta naught is what? Intercept. Beta 1 is X. Got it? ठीक है? Everybody understand that? Good. So let's go. So partial regression coefficients. What are these partial regression coefficients? Basically these values. Okay. So I have put that in like simple or bivariate linear regression has single regression coefficient. So basically single linear regression will have one coefficient only, which is our M here. Basically beta 1, right? Right. So in case of multiple, it will increase. We'll talk about that. So again, multiplication will have more than them, and we call them as partial regression coefficients. Constant term is called bias or intercept term. Okay. Change in predictive value per unit change in one independent variable, assuming all other held constant. That's how we interpret. Correct? This is in theory. Okay. We'll talk now. Okay. So intercept, also known as y-intercept. Okay. So it's basically why we call it as y-intercept. So y and x, right? X, y. So when I say y equal to mx plus c, so what will be the y-intercept? Point at which it hits the y-axis. Yes or no? That will be correct. And how my y will hit here? When x is 0. So 0 into m will be 0. Correct? Plus c. So this is c. Got it? For interpretation perspective, right? So now in our example, this is where it hits y-axis. Okay? Think from that perspective. Good. So you are clear with the intercept. Now standard error. It represents the average distance that the observed value falls from the regression line. So conveniently it tells you how wrong the regression model in average. Okay? On average, using the units of response variable, which is our y, smaller values are better because it indicates the observation are closer to the fitted lines. So let's assume this is a fitted line. So what can be a standard error? Right? Smaller is closer is better, correct? Right? So in our model, we have standard error. You can see that, right? Standard error. Okay. T statistics, estimated coefficient divided by its own standard error. That's mathematically T statistics. But basically what tells us? It measures how many standard deviation from zero the estimated coefficient is. And it is used to test the hypothesis that the true value of the coefficient is non-zero. You understand what this hypothesis means? See, okay. Y equal to mx plus c. Okay? Very simple. So y equal to mx plus c. I need to understand whether the m, okay, the m is non-zero. Because one way of putting y equal to c is what? My x becomes 0. Correct? There is other way of putting y equal to c also, when my m becomes 0. Yes or no? In both cases, there is no use of running this. Yes or no? So, I will hypothesize that my coefficients are non-zero. Yeah, negated, fine. But initially, I need to test this, whether these are non-zero or not. There are two ways of making this y equal to c, right? One is x becoming 0. Other can be m becoming 0. Right? So there is a measure. T statistics is basically tells me in order to confirm that independent variable really belongs to the model. Right? So in our case, what was independent variable here? Placement rate. It really belongs to the model or not? I have to test that also, na? So T statistics will tell me that. So in this case, ये सितारे देखते हैं आप लोग? Stars, right? You have to look for the star. This is the visual signal that whether it's statistically significant or not. 3 means more. 2 means less, 1 means अगर एक भी सितारा ना हो तो you should not consider it, right? Okay, placement rate is what? R, X, independent variable. So X1 is continuous. So beta 1 represents the difference in predictive value of Y for each 1 unit difference in X1. So basically very simple. C is constant. Basically beta naught is constant. So 1 unit increase in X, beta 1 units increase in Y. Very simple. Correct? Assuming it's positive. But in our case, it is negative. So it will be kind of decrease. Now, residual standard error is the estimate parameter. Assumption, basically, it tells me that the standard error, whatever is coming, is follows normal distribution. And what is normal distribution? Okay, so F statistics helps me to understand that all the independent variables, okay, all the explanatory variables taken together are able to explain the variance in Y above chance levels or not. In a layman terms, that's what F statistic is. आप इसको आप statistic level में किसी भी तरह fit कर दो, ANOVA वगैरह में complex हो जाता है. But अगर समझने वाली बात है, live simple to understand this, why I want F statistics. It helps me to understand whether all the independent variables together are able to predict Y above chance levels or not. Because in this case, only one predictor is there. So, but in multilinear regression, it's useful, right? F statistics. Single में तो एक ही है. तो obviously वो हमें it's obviously going to tell us about R square और वो सब हम बात करेंगे. But if I have multiple variables, taken all that together helps me to understand whether it's able to explain the variance in Y, basically able to predict Y, right, above chance levels or not. And now the next question is, what are chance levels? So tell me, very simple. Like, have you ever thought, we always say p-value should be as less as possible. Yes or no? It's a probability, right? Correct? So Y probability should be as less as possible. In what scenario it helps me? If you say p-value lesser is better, we say na, p-value lesser is better. And it should be less than 5%, right? That's how, we all has made it a threshold in the industry. But that's not true, but okay. So lesser is better. So 5% is something which we thought of. But why we always think p-value is lesser? Have you ever thought? Okay. So rarest of rarest. She said that, right? So what do you mean by rarest or rarest? Means that, we are dealing with data, okay? And I'm doing multiple computations to come to this number, okay? Which is my output, correct? So I always say my p-value should be rarest or lesser than lesser. Means what? There is one chance. Okay, there are some scenarios that this number has come out because of multiple computations. Yes or no? Sometimes you compute some numbers, okay, so many times that it comes out to be some realistic number which you are looking for. But there can be a scenario that it just came because of your multiple iterations. So it's kind of a fluke. You understand what is a fluke? हिंदी में क्या बोलते हैं उसको? तुक्का, right? So you say it can be true. So that's why I want my p value to be so less that I minimize that risk also. Okay? So when I say p value, it's probability that this event is rarest to rarest. Right? So that's why, I want p value to be lesser possible. If it's 0, it's great. But that's not possible. There's always something which you don't consider. So now when I say whether the predictor variables stated together predict the response variable above chance levels means above a p value which is very low, right? A probability which is very low, right? That's what I'm saying. And this will consider to every scenario, every model, every, right? You see this p here, p where the model will also be there. You seeing this? See this. It's how much? 0.4048, something like that, right? So this means this is a realistic number, right? The result is coming realistic. And definitely, placement rate has impact on number of applications. It means that. Guys, next one is what? Coefficient of variation, which is R square. What is R square? 62%. What does it mean interpretation wise? Of output variable, which is explained variable by the input variable. बस इतना याद रखना है. और numerically क्या होता है? बहुत simple. एक numerator होता है, एक denominator होता है. Ratio में. Denominator में क्या रहेगा? Total variance. और numerator में क्या रहेगा? Explained variance. बस. ये R square. कि मेरी टोटल वेरिएंस जो मॉडल में जो भी वेरिएबल्स में है, राइट, जो y में है, उसमें से कितनी एक्सप्लेन हो गई विद द हेल्प ऑफ x. बस ये याद रहेंगे. ठीक है. उसके बाद एक टर्म होती है एडजस्टेड R स्क्वायर. ये क्या होता है? इफ आई एम एडिंग मल्टीपल वेरिएबल्स, राइट, करेक्ट, इन द मॉडल. लेट्स अज्यूम आई स्टार्ट विद x1, देन आई एडेड x2, added x3, x4, x5, x6. So there will be a point where it, right. Or let's assume, I'll tell you another scenario, simple one. I had x1, I added x2, right? What will happen? All of a sudden my R square will shoot up, right? That's how, because I'm adding a new variable into it, right? So as per equation, it should shoot up. But adjusted R square tells me what? Whether it added some statistical significance to it or not. That's why when you compare models, adjusted R square is a better metric. Because you are dealing with data, right? So numerically, when you add one more variable, obviously R square will increase. Okay? But it genuinely explain the variance or not, that adjusted R square will tell me. You see this formula? K, 1 minus R square, n minus K, right? So basically K is number of independent variables. Okay? N is the number of records. Okay? So let's assume I have, okay, so in this example, what we were having, I'm having average placement rate, right? So now once we add mu variables, in case of multilinear regression, okay, you will come to know whether you explain variance more or not. So now, next time, if I want you to predict the applications using the placement rate and number of students graduating, can you do that please quickly? On the same model, add another variable, which is number of students graduating. Do that in R. You need R code? No? You'll do it yourself? Huh? दिखाऊं या ना दिखाऊं R code? Guys, this is the interview question. Huh? What is the difference between adjusted R square and R square? What happened here? This is the output you all got? So before this, let me explain. Same linear regression, y equal to beta 1 x1, I just added more. That's it. That's how it becomes multilinear now. Okay? From definition wise, that's how it changed. Okay? So before that, so this one was the output earlier, correct? So you remember our coefficient 13177.8. So this is how I'm going to get the equation for that, and I can get this output at a 60% rate, let's assume. Okay? This is manipulated data, so don't worry. How you do it? Something important. Correct? So we discussed this. So now output wise, you got a fair idea now about regression output? Okay. So this is basically another important way of linear association. Correct? So for example, if R square is 87.51, it indicates 87.51% of the variation in body weight is explained by the independent variable X. So BMI, which we call, right? Okay. So correlation and coefficient and regression. Okay. So correlation coefficient measures the strength of bivariate association, right? Regression is a prediction equation that estimates the value of x, value of y for any given x. So that's the difference, okay? So this is again a question, interview question it is. Like I'm like telling you, it's not anyway, but it's very simple. Somebody can ask you, right? What is the difference between correlation and regression? Bivariate. This is the equation. Least squares. You know what is least squares line? Regression line is also called least squares line. And there's something called OLS. Have you heard about that? OLS, ordinary least squares. So that is also regression only. I'm giving you different names so that you can, if you get your requirement document and they say build a OLS model, you should know what is OLS model. Okay, it's called ordinary least squares. So why we call least squares? हाँ, so errors को हमें minimize करना है और minimize कैसे करते हैं? Square करके, ठीक है? So इसलिए इसका नाम ordinary least square पड़ा. Okay? Least square क्यों बोलते हैं? क्योंकि हम errors को कोशिश करते हैं जितनी पास actual और predicted को ले आए. For example, let's assume this is a bottle which is orange color, this is red color, right? इन दोनों का difference अगर मैं निकालता हूं तो मुझे क्या पता चलेगा? हाँ, कि अगर मुझे ऑरेंज को रेड बनाना है तो क्या करना पड़ेगा, या रेड को ऑरेंज बनाना क्या करना पड़ेगा? गेटिंग इट? सो ये एरर्स जो हो रहे हैं ना, इसको हमें मिनिमाइज करना होता है. आई वांट टू मेक बोथ रेड और बोथ ऑरेंज. सो दैट इज एक्सप्लेन थिंग, राइट? अनएक्सप्लेन थिंग. अनएक्सप्लेन. व्हाट इज अनएक्सप्लेन? प्रेडिक्टेड वर्सेस एक्चुअल. अंडरस्टैंड? अच्छा, हैव यू हर्ड ऑफ दिस टर्म? वन इज वाई, अनदर इज वाई हैट. व्हाट इज दैट वाई हैट? प्रेडिक्टेड वन, राइट? वाई इज एक्चुअल, right? And what is error? Minus of this. That's we call epsilon in statistics term, right? We call it as epsilon, right? Okay. So how good is high R square? Okay. So high R square may not always be good. There is a residual issue. We'll talk about that. Okay. So there is something called assumptions of linear modeling, right? What are those? So lower R square may be better model. Okay. You can add more predictors or interaction terms. We'll talk about that. Decision of good fit is decision of goodness of fit is not solely determined by R square. Okay. Always remember, R square is not the only criteria to pick up a model. Okay. There are other things which you have to validate. What are those? We'll talk. So this is again fine, correct? Now my R square is what? 81. Earlier it was how much? 62, correct? And this is again, everything is significant. Now intercept becomes insignificant. You saw this? Observe this. Intercept becomes insignificant because of graduation number coming in the model. So these kind of things you have to pick when you're modeling. Okay, so again, same outer interpretation, right? 1 unit increase and all those things. Y equal to mx. Nothing, no bias variance, no biasness. So that is kind of that is kind of impossible, right? Okay, next one, guys. Same thing. Fitted. How to create a table between fitted value and residuals? So you can create a data frame. Okay, you remember we created a data frame, data dot frame. Student is my data set. Fitted values of the model. Residual equal to resid of the model. If you give that, this is how it comes, right? That's residual, fitted value. Okay, actual difference is that. What I defined adjusted R square as. I have some data, okay, and on some variable 1, okay. I'm using that variable 1 to predict my Y. Okay, very simple. I am able to reach to a prediction power, which I say explaining the variance with the help of R square. Now I want to improve that. One way to improve that is I increase the number of records, right? For example, I have 100 records right now. I'll make it to 1 lakh records. Let's assume. Okay? With the same variable. Okay? So, but there will be a point where my prediction power will be again 4 or 5% more, something like that. Again, this has to be done. So it will work. Other ways, I'm not able to explain variance in Y with the help of variance in X. Right? I should include more X into my model. Okay? So what I'll do, I'll bring another V2, variable 2. Okay? Or variable 3. Let's assume. Okay. So now what I see, my R square just spikes. So it was 60%, now it became 80%. Let's assume. Take this example, right? So now this is one is because I've increased the variables. Correct? So my regression equation will give me a better R square. Because more things to compute, multiplication बढ़ जाएगा. 1:2, 1:3. अगर आप background में how regression has been defined अगर आप उसमें जाओ, but you don't have to go there because you're using software. हम हाथ से regression नहीं कर रहे. Earlier people used to do computation of this. So now that is one thing. Secondly, जो मैं कर रहा हूं, whatever computation it is really valuable to the prediction power or not. For that, adjusted R square is there. And that's why I have k as number of independent variables in that formula of adjusted R square. You remember 1 by n minus k minus 1, something like that formula was there, right? Numerically was there. So now k, it's evaluating what? कि जो k increase किया है उसने prediction power बढ़ाई है नहीं बढ़ाई, आपको ऐसे याद रखना है, ओके? अगर आपको थ्योरम ऐसी है तो फिर उसमें टाइम लगेगा, like I have to explain the whole, you know, how this regression equation has been derived and all, right? Got it? Very simple. See, again, right now I know there are multiple sources, like you will find on internet, on books and all, which will explain in their own way. But at core level, what adjusted R square tells you that whether adding a new variable help me to increase my prediction power of the model or not. That is the bottom line, right? That you should always be looking for. Yeah, you can do that. Yes, that's why we got stepwise. You've heard about stepwise, forward selection, backward selection, right? This is how you do modeling. So if I have 100 variables, right? Just a sec. If I have 100 variables, right? And not 100, then I have to do PCA, okay? So let's assume I have 10 variables, right? And I found it, I started with 2 variables, build a model, then I got a third one, right? Make it a better one. I get to a prediction power. Then I got a fourth one, fifth one, or I started with 10 together. And then I started removing one by one. जो significant नहीं है उसको remove किया. फिर देखा बाकी 9 में से जो significant, कोई एक ऐसा निकलेगा जो significant नहीं होगा, right? उसको remove किया. एक टाइम पे आके saturation आ गई. फिर उसके बाद मैं एक और like what I can try interaction terms. What are interaction terms? Have you heard about this term before? No? You would have. I'll just explain you, then you will say, yes sir, we have. Okay, hold on. Where is the, okay. So example, see interaction term, what are interaction terms, okay? For example, guys, listen to this. You have employee database. Everybody knows about employee database, right? So you can have employee name, okay? Employee age, okay? Employee nationality, okay? Gender, correct? Right? Okay? Or qualification. Let's assume one more. How much qualified the employee is, correct? Bachelor, master's, postgraduate, or like a PhD or whatever, right? Okay. So now, see, let's assume I'll see graduate yes or no, or master yes or no, right? I'm calculating like that. So if the person is masters, I'll give 1. If person is non-master, I'll give 0. What does it mean? What are these kind of variables called? Categorical, but I'm making it numerical to compute what I'm doing. I'm making it dummy. Something called dummy variable. Have you heard that term before? Everyone understand what is dummy variable? If you don't, I'll explain you very simple. Gender, right? Male, female, right? Let's assume female is 1, male is 0. Okay? Fine. So female is 1, male is 0. Correct? So if I have data, if it's a female data, I'll show 1 there. If it's male data, I'll show 0 in that column. So basically earlier it was what? Male and female. It would have been difficult for me to compute in the algorithm. So what I did, I converted that into a numerical in nature. 1 and 0. Correct? So what I'm doing here, same thing, masters, yes or no. If masters yes, 1. If masters no, 0. Name is fine. Age, again it's a number. I can again do this also. If it's young, middle age or senior citizen. Categorical class is different, right? You can have 1, 2, 3, 0, 1, 2, like that, okay? Again, what is this? Employee, which is age, nationality, right? So let's assume Indian, non-Indian. Okay, Indian or foreign, like let's assume. Okay, so Indian 1, foreign 0. Correct? So I have a 1, 0. Let's assume. Gender, female 1, male 0. Got it? Okay? What I will do, I'll do modeling. Let's assume I'm predicting something. Why? Let's assume I'm predicting efficiency of employee. Let's assume efficiency of employee. So what I'm doing, I'm regressing this with all these, right? Got it? So at one point, I get saturated with my variables. I'm able to explain maybe 70% of variance. Let's assume. I'm just taking hypothetical number here. Okay? So now, to improve my variance, other thing which I can try is interaction terms. What does it mean? I would like to see employees who are masters and who are Indians. How I can get that? I can multiply these two columns and make another column. Yes or no? Right? So 1 and 1 here make this also 1. 0 anywhere will make this as 0. Yes or no? And then I'll regress again, another iteration of model. I'll see whether this new column, which is master underscore Indian, comes out significant or not. Yes or no? So there can be a scenario that this can explain me to get the efficiency of employee better or not. An Indian who is master or a foreign who is master. Again, I can go with gender also. Females who are masters. Females master Indian. I can go to 3 levels. You getting it? So basically I'm increasing number of variables. So now R square will definitely increase. But adjusted R square will tell me whether it helped me to explain variance or not. That there the significance of adjusted R square comes. Confused or clear? Clear? Example se clear hua? I can take thousands of examples like this. But you have to always think, देखो simple है. Data मेरे पास है, right? You remember I used the term, it's art and science both. Yes or no? Correct? What this is artistic. Yes or no? You're creating variables for yourself. You're being artistic with your data. Science is what? Regression modeling. आपके पास एक मॉडल है, एल्गोरिथम है, ऑलरेडी प्रूवन एल्गोरिथम कि मेरे को नंबर निकालना है, I'll use regression. ठीक है? लेकिन उस नंबर को, उस एल्गोरिथम को देना क्या है, आउटपुट, इनपुट क्या देना है, दैट इज आर्ट. So never stop yourself for trying anything in regression world because it's completely experimental in nature. And there is no yes or no for a perfect model. You can spend your age to create a perfect model. You might not reach it there. So that's why I said, you remember? Stop. Remember? You have to stop somewhere. Okay? That's why people get lost in regression analysis because it's so intuitive. You are so against the perfect relationship that sometimes you overdo things. That then there comes the problem of overfitting and underfitting. Okay? We'll explain. Okay? So shall we start? Assumptions. So error or residual terms are normally distributed. Okay? So you know normal distribution. Okay? Second one is constant variance of the error terms. We call it as homoscedasticity. Okay? Independent variables are not correlated. That is no multicollinearity. If multicollinearity exists, it's a problem. Okay? Error terms are not correlated to any of the independent variables. What does this mean? So, okay, so real terms, good, you're right track. So it basically tells me that something is left. When I see a pattern there, it means something is left which can explain variance for me. That's it. When your error shows a pattern with your X, means what? Right? Something is left in the data which can explain more variance for me. Exactly. So whatever X you have considered is not able to cover that. Very simple. From a simpler terms, right? No statistical, very simple terms. What does it mean? That there is something left in the data which I still need to evaluate and improve my model. How we'll do that? We'll talk later. Okay? Dependent independent variables should follow normal distribution. Again, relationship is linear and additive. Okay. So how you check whether other residual terms are normally distributed? Basically, with the help of skewness. For a normal distribution, skewness should be 0, right? Okay. Kurtosis, curve is neither too peaked nor too flat, and there should be no outliers. Okay. So how you can do that? With the help of histogram, box plot, QQ plot, right? These are the plots which helps you to do that. Residuals are independent of X. So basically what you will do, you will plot residuals of model with fitted values of the model. It should come as this pattern. This is random in nature, right? This is expected output. Correct? Random hone chahiye. They should not follow pattern. Means that it should not be any linear pattern or quadratic or anything like that. Try to avoid that. If that happens, okay. What about non-normality? Let's assume it's non-normal. See, we discussed favorable cases, right? What happens if favorable cases are not there? What you should do? Yes, transformation. And how you will decide which transformation will work? Okay. So if positive skewness is there, log will work. If negative is there, square will work. So I'm still giving you rule of thumb. You can use this. One other way of coming up which transformation of what variable, what is that? In your stats class, you would have studied this. Which transformation for which variable? How you decide that? you should always try to find a data distribution of that variable and accordingly decide which transformation to go for. And I'm sure data distribution you have covered in your stats class. So next one is heteroscedasticity. Okay. So word heteroscedasticity comes from heteros, means what? Different. Okay. Heteros means different. Okay. Cedasticity means conditional variance. So when we combine this, it becomes different conditional variance. Okay. So our original assumption was what? There should be constant variance, which is homoscedasticity. So homoscedasticity is desired. Correct? Heteroscedasticity is a problem. So these are heteroscedasticity problems. The variance is not constant. So see this. This is constant. This is quadratic. So इस केस में कुछ नहीं करना, इस केस में कुछ ना कुछ करना पड़ेगा. ये आपको समझ आना चाहिए. If heteroscedasticity is there, you should treat that. Okay? So heteroscedasticity when error variance changes in systematic pattern which changes in the X value. Okay? So sources, they are error learning models. As the income increases, saving not only increases but the variability in saving also increases. Yes or no? Let's assume my X is income. मेरी सैलरी बढ़ेगी तो मैं सेव भी ज्यादा करूंगा और डिफरेंट ऑप्शन में सेव करूंगा. Yes or no? हो सकता है मैं पहले like I was a fresher, I only save in fixed deposit. Once I become a manager, right? I might buy a house, right? So I start putting money for my house, right? So that is there. So that will always be there. So we have to identify as per domain whether heteroscedasticity is good for my domain or not. Okay? Sometimes as per domain it will be there. You can't do anything. Okay? So reason for that can be, there can be some omitted variable that you have not considered some variable. That's why it's there. Skewness in distribution and incorrect data transformation. So you might have, used some incorrect data transformation. Maybe say linear X instead of quadratic X. Okay. So how we did it, I'll just tell you. So first of all, detection. So one is scatter plot, right? Other way is that you can plot squared residual against each of the independent variables. Alternatively, the number of regressors is large. Let's assume your regressors are very large. Okay. Plot the square residuals against the predicted Y. That will also tell you because it will take effect of all this because you have predicted Y and already all the variance is there in predicted Y. So you can check that. So again, possible patterns. So what we learned, linear model assumption. First assumption is what? Error should be normally distributed, right? How to go about that? नहीं वो तो हम कहेंगे लेकिन चेक क्या करना है? Skewness देखनी है, kurtosis देखना है, right? और देखना है कि कौन हाँ outliers देखने हैं. Good. तो कैसे करेंगे? With the help of histogram, QQ plot and box plot, right? ठीक है? So that's one error. Second is I want उससे पहले एक और independent of X. ठीक है? Right? That's second one. Third one is conditional variance होनी चाहिए मतलब कि heteroscedasticity नहीं होनी चाहिए, homoscedasticity होनी चाहिए. Okay? There should be homoscedastic. Got it? ठीक है? And how we treat that? So before that, right? Someone can ask, why is it so important to detect heteroscedasticity? Why it's so important, right? Correct? So one is that, see, biased standard error estimation, inferences based on OLS estimation becomes inaccurate. So because you will go and say that, that this coefficient, this minute increase will get this, but you see still the pattern is there, right? So there can be a scenario which will make your assumption or the prediction inaccurate. Correct? Possible solution, which is always there. Huh? What? Transformation. So best way to do is, one is transformation, but we have to hit the exact transformation. How we will do it? Let's consider a scenario. Suppose in a regression model, output plots, we see that the value of squared residue increases with X. Okay? To eliminate this effect of increasing variance with X, we divide both sides by X. So by doing this, there is a new error term which is epsilon by X. We've considered that as U. Right? यहाँ पे अगर मैं X से कर दूंगा तो epsilon by X आ जाएगा. उसको मैंने equate कर दिया U के साथ. Okay? So let's look at the scatter plots. So this is the original one. So do we see any pattern here first of all? Can I say it's a quadratic? Maybe I have more data, it will be more clear. But if you see this, it started from here, slightly goes up, like this. So kind of curve. Right? Correct? So I remember I said if a degree of polynomial is more, I can divide by that same number, it will come 1. Yes or no? So now I divided x in that. Correct? So once I divide by x, what will happen? Pattern is gone. So now I'll do a remodeling of that variables and come up with a better model. So my heteroscedasticity goes away. मैं इसका शॉर्टकट दूंगा बाद में, अभी थोड़ा मुश्किल तरीके से समझ लो. Okay? हाँ. Because I was regressing with a higher degree. Now I've reduced the degree of the polynomial and now I'm getting it the same. Like I was regressing with x square maybe. Because x is showing you this, right? Let's assume placement rate है, let's assume. ठीक है? आपको placement rate 100 दिया हुआ है, let's assume. Maybe originally जो y के साथ है वो 10 है, let's assume. Assume कर लो, ठीक है? तो अगर वो 10 square था, तो 100 दिया था वो नंबर. अगर मैंने उसको डिवाइड कर दिया तो मैंने उसको रिड्यूस कर दी डिग्री 1, एक डिग्री, और मैंने उसको फिर y के साथ रिग्रेस करके देखा. Yes or no? तब मुझे पता चला कि वो मेरा जो assumption है वो सही है या गलत है. I'm just testing that, na? So I just tested that now. So again, this is something which I have shown you, which I have come up with. You will not get into this perfect world, okay? You have to try multiple ways to get to there. It's not that you try one transformation, it will work. Okay, other transformation, plot of squared residual against x might show a linear shape as opposed to quadratic. Then the square root transformation, divide both sides by square root of x. Logarithmic transformation, regress log y on log x compresses the scale in which the variables are measured, thus reducing the range of variance. जब आप log करते हो, वो compact करता है उसको. So range of variance is reduced. So that can also help you to get the heteroscedasticity away. Whenever you see a problem, okay, which is predictive in nature, always try to get to one answer to it. You know what? What is my output I'm looking for? Okay. So output can be two ways, right? One output can be either a number, yes or no, ठीक है? Sales value, profit value, right? कुछ भी हो सकता है. Number, efficiency, anything, number or scale. One is that, or rank, anything like that, right? Second output can be what? Class. Class means what? Yes, no, good, bad, fraud, non-fraud, sick, healthy. समझा आपको? ठीक है? हाँ, फ्रॉड नॉट ऑल दिस ऑल क्लास. तो इसी टाइप के दो तरह की प्रॉब्लम आपके तरफ आएंगी हमेशा. दो तरह की प्रॉब्लम ही आएंगी, एक आएगा नंबर या फिर, ठीक है, जब ये आ जाए, जब आप ये एक्सरसाइज कर लेते हो, व्हेन यू एवर हिट अ प्रॉब्लम एंड यू डू दिस एनालिसिस इन योर ब्रेन, योर वर्क इज सो इजी. यू नो व्हाई? डिपेंडिंग ऑन व्हाट काइंड ऑफ रिस्पॉन्स वेरिएबल यू हैव टू कम टू, योर टेक्निक विल बी डिसाइडेड. हाँ, क्लासिफिकेशन या रिग्रेशन. सो या आपको रिग्रेशन करना है या क्लासिफिकेशन करना है. तो उससे क्या होगा? रिग्रेशन के एल्गोरिथम अलग है, क्लासिफिकेशन के एल्गोरिथम अलग है. तो आपके दिमाग में एक लिस्ट बन जाएगी कि मुझे अगर रिग्रेशन करनी है तो मैं लीनियर रिग्रेशन से स्टार्ट करूंगा, फिर उसके बाद मल्टी लीनियर पे जा सकता हूं, फिर उसके बाद मैं उसको इंप्रूव करूंगा, और आई कैन गो टू यू इन डेटा माइनिंग. यू विल स्टडी अबाउट दिस, सो डोंट रैंडम फॉरेस्ट एंड ऑल व्हिच आर नॉन पैरामीट्रिक, पैरामीट्रिक, ये सब चीजें. और अगर क्लासिफिकेशन है तो मुझे लॉजिस्टिक्स से स्टार्ट करना है, देन आई हैव टू स्टार्ट विद नियरेस्ट नेबर, दिस ऑल एल्गोरिथम्स. बहुत आसान हो जाता है अगर आप पहले एंड पर ही ये सोच लो कि मुझे किस पाथ को फॉलो करना है, बस. ठीक है? हेल्प्स? सिंपल, वेरी सिंपल. इफ यू आर नॉट फ्रॉम द एनालिटिक्स वर्ल्ड, दिस इफ यू स्टडी लाइक दिस, आई एम श्योर योर लाइफ विल बी इजी. कॉम्प्लेक्स वर्ल्ड के लिए दुनिया बड़ी है, पहले सिंपल तो सीख लें. ओके, फर्स्ट फाउंडेशन स्ट्रांग रखो.
This brings us to the end of this tutorial on linear regression. Now, before you guys sign off, I'd like to inform that we have launched a completely free platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. So thank you very much for attending this session and have a great learning ahead.